At the scale of millimeters, a honeybee, wings beating 200 times a second, homes in on the ultraviolet glow of a pristine white orchid. The bee lands, expecting a meal. Instantly, the flower fractures. Smooth petals reveal serrated limbs that lock around the bee's thorax, pinning its wings. For over 100 million years, flowers and bees have operated on a strict biological contract known as the honest signal. The flower spends energy producing nectar, and in return, the bee transports pollen to the next plant. It is a system built on a mutually beneficial exchange. But an entire ecosystem of predators has learned to read the terms of this ancient contract, locate its vulnerabilities, and write themselves into the code. Nature's greatest promise is being subverted in your backyard. Discover the dark side of pollination, where these saboteurs have transformed the evolution of attraction into a masterpiece of deception. The orchid mantis, Hymenopus coronatus, utilizes aggressive mimicry to function as a destination. This disguise is designed to lure prey in, rather than hiding from predators in the background. To pull off this illusion, the mantis has to physically reconstruct itself at the microscopic level to replicate its tropical environment. If you look closely at its legs, specifically the femoral lobes, you can see how its biology replicates botanical geometry. The edges of its exoskeleton curve and taper to match the surface area and veins of a natural orchid petal. Because of these identical contours, a pollinator scanning the canopy sees no break in the visual pattern. The predator is absorbed into the floral backdrop, appearing as a blossom to the naked eye of a foraging bee. The mantis's physical form is a biological counterfeit, sculpted over millennia to manipulate visual perception. But looking like a flower is only half the equation. To consistently draw prey, the mantis has to manipulate pollinator psychology. The mantis releases chemical pheromones and ultraviolet cues intersecting the bee's sensory nodes. Watch the signals bypass defensive nodes, flooding the primary neural pathway to suppress caution. This supernormal stimulus dwarfs natural signals, convincing the bee it found a hyper-exaggerated flower. This bar chart compares the quantitative pollination attraction rates of the orchid mantis against surrounding natural flowers. The results reflect a measurable reality. The mantis attracts significantly more traffic than the actual nectar-producing orchids resting inches away. The mantis outcompetes the genuine article, weaponizing the bee's own deeply ingrained desires to lead it into a trap. After a successful strike, the mantis simply resets. It shifts its posture among the neon-colored flora, locks its geometric limbs back into position, and waits for the canopy to deliver its next meal. Humans tend to view floral beauty as a passive trait. We associate vibrant colors and elegant petals with gentle growth and quiet ecosystems. But in these corners of biology, beauty is active. It is a calibrated tool designed to control behavior. Survival in the wild is usually associated with thick armor, speed, or brute physical strength. Yet the deadliest predators often bypass force entirely. By mastering the mechanics of attraction, the mantis proves that evolutionary success frequently goes to the most effective liar.